Good morning, guys. Sorry, guys, to keep you waiting. I just had a disaster with my cup of coffee. I knocked it all over the desk just as we were about to start. So, all right. Sorry about that. I've started recording so we can start our class. And let's go ahead and have a look. Okay, so I don't know who's online and who was here on our first boot camp, but if you do remember that I said what we would be doing today is on our first boot camp, we had a look at revision for Learning Unit 1 and 2. And then today we're going to have a look at some revision for Learning Units 3 and 4. And then thereafter, we're going to go ahead and take a quick look at some of the others and then go through the actual assessment so that we can give you some support on the actual assessment papers themselves. Okay. So what I've done is I have just prepared some slides for you here just to show you the learning objectives for LU3 and 4, so you can see what it is that we will be covering. And again, just to remind yourselves exactly what it is that you are expected to know and what you will be tested on. Okay, because remember, the learning objectives is really what you will be tested on. Okay. Okay. So this is just our little overview of the two learning units, 3 and 4. So learning unit 3 is called Risk and Return. And remember that I said it was also one of the foundation learning units that you guys have to cover. And the reason that they put them right at the beginning of the module is that these foundational learning units, the concepts and formulas, etc., that we learn here are critical for the rest of the applications that we do. So we've already looked at the role and environment of the financial manager and time value of money, hugely important for the rest of the module. And so third learning unit is then risk and return. Because everything that we do as a financial manager has to be built into our decision-making process. And then learning unit 4, we look at interest rates, which again is a foundational concept. If we don't understand how interest rates are constructed and how they are meaningful to us as financial managers, then that's difficult for us to then later understand when we apply interest rates, both in time value of money and then in discounting cash flows, bonds, share valuations, bond valuations, and capital project valuations. So for LU3, here's our learning objectives, just to go through. So risk, the fundamentals of risk return and risk preferences, the procedures for assessing and measuring the risk of a single asset, and then also the standard deviation and coefficient of variation of a single asset, and then also the same thing for a portfolio. And then we specifically look at a portfolio and the risks in a portfolio in terms of the concepts of correlation and diversification. Okay, and we have a look at international assets as well. And then also very importantly in learning unit 3, it's not here in our learning objectives, but the types of risk, systematic and unsystematic risk, please remember that that's extremely important as well. Then for our learning unit 4, excuse me, we've got that split into two parts. The first part covers interest rates and their structure and interest rates fundamentals. And then in the second part of LU4, we have a look at bond valuation. So bond valuation, guys, is really the very first application that we then got of what we have learned about time value of money, interest rate fundamentals, and those other concepts of risk and return as well. Okay. So finally, in LU4, we start applying our theory. So with bond valuation, we basically learn what all the cash flows related to a bond mean, where they come from, and how we can calculate them. We then apply the time value of money to the timing of the bond's cash flows, and then so that enables us to come up with a valuation for the bond, so that we can then decide whether we want to buy it or sell it and how much we should be getting for it. And then the very last thing in LU4 is then to we have a look at the concept of yield to maturity and how we calculate that. And essentially what we're doing with yield to maturity is it's kind of like calculating the break-even discount percentage for a set of cash flows for a bond. Okay, so it's solving for R. Remember, in time value of money learning unit, right at the end of that module, you had those series where we had to solve for R and solve for N, etc. This is the first application of that concept there. Okay, has anybody got any questions at this stage? Anything that you want help with from your revision that you've done so far? I'm not going to be taking questions on the assessment specifically today, because remember, we will be doing those individually, because otherwise, if you ask me a question on the assessment now and how to do a particular question, we'll take up all the bootcamp time with that, but we will have plenty of time for that. Okay. Okay, so then looking at learning unit 3, I just want to go back to my learning objectives over here. Okay, so this is risk and return. These slides start at the section where we look at a portfolio, and we look at correlation and diversification, which also are concepts that relate to a portfolio itself. And remember, guys, all of these slides that we're doing here in class are uploaded to that shared folder, the shared bootcamp folder, so you can go and get them there. I assume you can download them from there, and then you can have a look as well. So let's just go to this part here. So the first part of learning unit 3, definitions of risk and return. And guys, this might sound silly in third year to be learning definitions, but it really is vital that you understand, in terms of financial management, how we as financial managers are going to use the definition for risk and return. Okay. So if you have a look at page 66, I hope you guys have all got your textbooks with you, because we will also be referring to the textbook as we go through. So page 66, we have got our first definition there, which is the definition of risk. So how do we understand risk from a financial manager's point of view? Okay. As financial managers, we will be calculating estimated cash flows and projected returns for budgets, forecasts, capital projects, all sorts of things that we do. So our job as financial managers is to continuously estimate what is going to happen from a financial point of view and a profit return point of view in the future of the company that we work for. So risk is then the probability In your books, they say that an investment, but remember the investment could be the annual returns, the annual results of the company, or it could be a capital project. The risk or the probability that that investment will yield a return that is different to what is expected. So our estimated cash flows, our estimated budgets, etc. Risk means how big is the probability that what will really happen in reality is going to be different from what we estimated. Okay. So in formal terms, risk is defined as the probability that an investment will yield a return that is different to what is expected. So basically, we're talking about volatility because really risk, we do always expect that the results are going to be slightly different from what we estimated, because we know we're working with estimates and we know that reality will never land exactly where we've estimated. So risk is basically related to volatility. In other words, the larger the deviation from our expected return, that volatility, the bigger the volatility, the bigger the risk. So do you remember the word range? We say that we measure the risk by measuring the range. Can anybody remember what the range is? How do we measure range as relating to risk? How do we measure range? Can you remember? Because the bigger the range, the bigger the risk. So range says the best case scenario minus the worst case scenario return. The larger that rand value or percentage value is, the risk there is in my project. Okay. So far we're looking at, we want to understand what expected return is. We want to understand what range is. We want to understand what volatility is. Okay. And then where we've got definition of risk, they also talk about uncertainty, because you also have to know the difference between risk and uncertainty. So uncertainty is just, again, I've got an expected or estimated return. Uncertainty is the fact that the outcome could be different from what I expect. Okay. So in other words, what are all the different outcomes that could possibly happen? And then that's uncertainty, because then I become uncertain as to what the actual final result is going to be. So formally in your books it says uncertainty is when a financial manager cannot identify all the different possible outcomes, or otherwise he can identify the possible outcomes but is unable to assign a probability to each one of the different outcomes. So in other words, he knows that there's 5 different scenarios that could possibly happen, but he doesn't understand how likely each one of the different 5 is likely to happen. In other words, as far as he knows, any one of those 5 vastly different outcomes could be the thing that happens. So he can't assign a probability. That's uncertainty. And then risk is the measurement of the difference in outcome from the lowest of the 5 to the highest of the 5. That range is then the measurement of risk. Okay. Your question 3.1 on page 68, you can practice that. That's, again, something that you must understand. What is firm-specific, shareholder-specific risk, and then some risks apply to both shareholders and the company itself. Then on page 69, you guys have got your definition of return. Okay, so we've looked at risk and uncertainty, very NB. Now we are looking at the definition and the formula for return. So we usually call this profit. Return can equate to profit, but we have to have a formula for it. So we say that again, the definition of return is that it is defined as either the gain or the loss, because you can have a negative return as well as a positive, of an investment over a known period of time. So in other words, I've got a particular investment. I want to know what my gain or loss for this financial year has been. And we usually calculate return as a percentage. Okay, it's usually expressed as a percentage. Remember from second year, we did our ratio analysis, gross profit and net profit, etc. That was you calculating your return. And the reason that we express it as a percentage, because yes, we can calculate it as a rand value, but when I'm comparing the returns of 5 different projects, if I just mention the rand values, that's not going to be very informative to me. If I compare them, because the projects might be all of different sizes, and one might last for 1 year, another one might last for 2 years. So that's why I use a percentage, because a percentage is a meaningful comparison. And then our formula says that return is calculated by taking what I paid for that particular investment when I first bought it, minus what the selling price of that investment is worth on the market now. So in other words, my capital increase in value. And then I add to that any cash flows that I have received from that investment over the time that I have had it, or over the time that I'm measuring. And then once I've got that total rand value return figure, I then calculate that as a percentage of the price that I originally paid for that asset. Okay. So that's how we basically break down that formula for return on page 69. And take note of that formula, because we're now going to apply that formula when we look at procedures for assessing the risk of a single asset and a portfolio. So your next learning objective or main point here is risk preferences. And again, you guys have to understand this. So we just need to understand the difference between a financial manager or a company who is risk averse, risk neutral, or risk seeking. So that you can go through on page 71, and that should be self-explanatory. And I'm sure you guys remember that from when you did it earlier on in the year. And again, the reason that as financial managers we need to know that is because when we then have to apply risk to our decision-making process as a financial manager, we have to be aware of what risk preference our company has, so that we can then apply that to our decision-making procedure. Then we come to assessing the risk of a single asset. So we first of all have got 2 individual methods that we can use, and that's either sensitivity analysis or probability analysis. Okay, so sensitivity analysis is when we say, what if? And we then take one of the key variables in our estimates and we change that perhaps for 3 different possible outcomes. And we see what flexing that one variable effect will have on the return of the project as a whole. And in this case, where we've got best expected worst case scenario, this is here where we can calculate the range of the outcomes of our product. Okay, so sensitivity is basically testing the sensitivity of the return of our project based on if one of those particular variables was to be 10% higher or 10% less. And when we've completed that exercise, we will then know how sensitive the outcome of our project is for each of our individual variables or inputs that are required in that particular project. Okay. So your example 3.3 is then where we do a comparison And we calculate project 1 has got a range of 9%, whereas project 2 has got a range of 12%. So remember what we said, that the larger the range, the riskier the project. So we would then obviously choose project 1 because it is less risky than project 2. Also obviously taking into account the risk appetite of the company that we are working for. And then as always, remember wherever they've got advantages or disadvantages or pitfalls, etc. Page 72, they've got some pitfalls to use in sensitivity analysis. We always have to, those are very important sections. You had them all the way through second year. They also have them all the way through your third year text. It's very important that you're aware of those specific issues and assumptions that we have to make when we are using one or other type of procedure or technique. So sensitivity analysis versus probability analysis on page 72. With probability analysis, we are, remember when we said uncertainty, we understand that there are several different possible outcomes that our project could have. And in this case, we are going to try and assign a probability to each one of those different outcomes actually occurring. The important thing here is to remember that all the probabilities that you assign, if you've got 5, in this case, we've got 5 different possible outcomes. The probabilities of the 5 must add up to 1.0 or to 100%. Our calculations will only be meaningful if that is the case. And then you've got the actual calculation on page 73 of the expected return of a project. So what we're doing here is we're actually applying that formula for calculating return to our project. Remember, return says if I'm calculating return of my project, which is going to be a percentage, I take the cash flows associated with my project as a percentage of the price that I paid for it. So that's exactly what we're doing here. We are going to take for project 1, we calculate the expected value for each project separately. So for project 1, I take the probability of each one of the 5 outcomes and I multiply it by that outcome. And then when I've got all 5 calculations, I add them together. And that total is then the expected value of the project. And remember, we don't have to do any averaging at the end of this calculation, because by applying that probability percentage in that way, I have already weighted my outcome for 100%. So in other words, my annual return for project 1, if it was very bad, is going to be 15%. I've got a 12.5% probability of the outcome being 15%. So I'm only going to take 12.5% of the 15% and add that into my expected value. So in that way, we calculate for project 1 an expected value of 34.75% and for project 2, 22.88%. So we can also substitute, instead of saying expected value, we could also say expected return, or just return of the project is what we've calculated there. And then to practice these concepts, you've got question 3.3 on page 73, where they ask you to calculate the range, to calculate the expected return for each project, and then most importantly, to be able to make a decision as to which of those 2 projects you guys are going to choose. Then we come to the concepts that we apply for a portfolio and a single asset, and that's standard deviation and coefficient of variation. So on page 74, you've got two formulas for measuring standard deviation. So standard deviation is the statistical measure for risk. Okay, so we used probability analysis and sensitivity analysis as kind of like scenario planning around our risk. If we want to get more specific numerically, we use a statistical calculation, and that's what standard deviation and coefficient of variation are. So we just put in a more accurate quantification to our risk. The reason that you've got two different formulas on page 74 is because in the first formula, you'll see that that's the only formula that has got the variable pj, which represents the probability of each particular outcome happening. So you will only use that first formula if you are given probabilities for the different outcomes. If you don't have probabilities, you then will use the second formula, which you will see also uses the return of the particular, it could be year or project, Rj, minus the expected return squared over n minus 1. But you'll see in that formula, there's no mention of a probability. Both of those formulas measure standard deviation. You just have to decide which of the two formulas you're going to use depending on what information or variables you have been given about the asset that you are measuring. Okay, so that's important because I know that's one place that the students get confused as to why have they got two formulas. And then that's demonstrated in example 3.5, where again we've got the 5 different outcomes that we had on the previous page with the project return. So here we're using project 1 from the previous example. And we are now going to statistically calculate what the risk, the quantity of risk is linked to this project 1. So you can see in the last column that says variance. That's the calculation that we're doing. Outcome very bad, I take 0.125 or 12.5%, which is my probability. Excuse me. And I multiply that by the 15% minus the 34.75% squared. Okay. So if you were doing this on your calculator, you would do it in the order of 34.75% minus 15%, but without using that percentage on your calculator keyboard. So you would just on your calculator, you would say 34.75 minus 15, get your answer, take the square of that answer, and then multiply that result by 0.125. And that's how you then calculate the 48.76. Then you do that calculation for each individual possible outcome. Taking note that if you added up all the probabilities in column 1, they would total 1.0, 1 whole. And then most importantly, and again, this is one of the things that the students often forget, is then they forget to take the square root of that sum. So we sum them, we get 127.45. You must remember to then take the square root of that, and then we get 11.29% as our standard deviation. So again, that 11.29% now represents the distance that all my possible outcomes have on average from the expected valuation or the mean. So now I've calculated, we use that, we use the symbol theta to represent standard deviation. So our coefficient of variation is then going to be theta divided by RE. So remember, RE was our original expected return that we calculated, or expected value. So if theta represents risk, what I'm doing now is I'm saying the total quantity of risk for this project divided by my percentage return. So what I'm doing is I am calculating the quantity of risk per each percentage return that I expect to get from the project. So again, what I'm doing here is I'm calculating something that's going to be comparative from one asset to another asset. Because if I calculate the coefficient of variation for 3 different assets, I can then compare those 3 answers, and I will then know what quantity of risk I am letting myself in for each 1 percentage point of profit. And then obviously the higher the coefficient of variation, the higher the risk in that particular project. Okay. Then on page 77, and I'm not going to go through this lot in detail because we then just apply procedures for measuring the risk and return to a portfolio as opposed to a single asset. So you've got your formula on page 77. The return of a portfolio is equal to the weighting of that particular asset's value in my whole portfolio multiplied by the return of that particular asset. But again, guys, what you're doing here is the same as our little return formula on page 73. In essence, we're calculating RP is the same thing as saying EV, expected value, or RP, or RE, my expected return, is equal to the probability of a particular outcome multiplied by the return of that particular outcome. So probability and PJ and weighting, WJ, those basically mean the same thing. Weighting and probability represent the same concept. And again, if I've got 3 different assets in my portfolio and they will each have a different weighting, the 3 weightings added together must equal 1. Okay? 1.0 or 100%. Just like all probabilities added together must equal 1. So you're doing basically the same thing. The only thing to take note of here, and this is where the students always get muddled up in the exams, they get caught out every time, is in example 3.7. You have got 3 different assets, and we have got returns for those assets over 4 different years. And often what the students do is they try and calculate a return per individual asset and then compare the returns of the 3 different assets. But remember, if you're doing that, you are calculating the return of a single asset. Here we're talking about the return of a portfolio, which means for each individual year, what was the return for my portfolio? So you are here going to calculate the expected return per annum and not per asset. Okay? So that in each year, I will take the return of each of my 3 assets, average them to get my return per annum, and that will be my portfolio return. Because a portfolio means you've got more than 1 asset. And then measuring the standard deviation of a portfolio and the coefficient of variation for your portfolio works in exactly the same way as we did for a single asset. Same formula, everything. Okay. And you've got example 3.8 to measure that. And again, guys, here, just look at example 3.8 in your textbooks. Because we've got a portfolio, and I am also in this case, besides the fact that I have got a portfolio of more than 1 asset, I am also calculating my return over the period of 4 different years. So I've calculated my expected return for each individual year. Then I have calculated the average expected return for the 4 years, which is the 9.76. And then to calculate the standard deviation for each individual year, I am going to measure the difference between the return for that year and my expected return for the portfolio as a whole. So here, because I have got 4 different years, I'm going to calculate my variance for each of the 4 years, and then I'm going to add them together, and then this formula tells me to then divide it by n minus 1. So n would be 4 because n represents how many years have I calculated it for. And then it says to minus 1. So 4 minus 1, I'm going to divide the answer by 3. And in that way, I'll get my, and then I take the square root of that answer and get my standard deviation. Okay. Which in this case, we are using this, if you look at page 74, we are using the second formula, the formula where we are not given a probability. So the only reason I'm using that formula is not because it's a portfolio, but because I don't have I'm not given a probability. If we were given probabilities, we would also have used that first formula. Okay, so hopefully that's caught you up and reminded you and revised you about risk and return, calculating expected value, calculating standard deviation and coefficient of return, and what all of those figures actually mean. Just sorry, excuse me, I'm just going to take a quick drink of water. Okay. So now we can go on with the slides. You can have a look at the slides as well as having your textbook in front of you. We now need to understand what correlation means and diversification. So really, if we just look at the summary on the screen with the slides, correlation describes how strong the relationship is between 2 variables. So what we're actually looking for is there a relationship between 2 different variables that I'm looking at? In other words, are they affected by each other? Or not only affected by each other, do they behave in the same way as each other behaves when something in their environment changes? Okay, so here are my 2 variables. They're living in the same environment. When something in that environment changes, those 2 variables, do they behave in the same way, or do they behave in completely opposite ways, or is one affected and the other one doesn't change at all? That's a good way of looking at it. So if those 2 variables, if something in the environment changes, if they behave or change in the same way, then there is a positive correlation between them. I've identified that there is a relationship between those 2 variables because they behave in the same way to outside influences. If they do both change, but they're changing in completely opposite directions, then they are correlated, but they are negatively correlated. And if one of them changes, if something changes in the environment, and the other one is not affected, then I can say that those 2 variables are not correlated at all. So numbers are positively correlated if they move in a similar direction to any changes, and they are negatively correlated if they tend to move in equal but opposite directions. Okay, this part over here about correlation is typically measured using a correlation coefficient denoted by R. You can read that for interest's sake, but you're not going to be tested on that. And you can have a look at the graphs on page 79, that part at the bottom there. Look at the graphs on page 79. that's a graphic illustration of positive and negative correlation. And if you can visualize that, then that will really help you to understand that. And then you've got question 3.5 on page 80 that will help you to revise everything that you've learned so far in this learning unit, so you can use that to practice. It is a portfolio, so you will be calculating standard deviation and coefficient of variation. You also have to calculate the expected return of each individual asset, and then the expected return of a portfolio. So that's a really good question to practice, the question 3.5. And then our second concept that we need to understand here as investors is diversification. And what that refers to is the fact that I have got more than one asset in my portfolio. So as soon as I have more than one asset, then I have a portfolio, because the word portfolio means a collection of something. So if you refer, you might often have heard that referred to as an artist. An artist has a portfolio of the work that he has done in this particular year. Then that would be a big folder with all of the different artworks that they have done collected together. So it's a portfolio as a collection. Okay. If you only have one asset, you can't possibly be diversified, because in order to be diversified, that implies you have got more than one asset. And the whole reason why we do diversify as investors is because we want to spread our risk across different environments, across different industries, etc. And by doing that, we reduce the risk of our portfolio as a whole. Okay, so the principle behind diversification is that the value of the whole portfolio is greater than just the sum of its individual parts. So, for instance, if there is little or no correlation between movements in the assets in my portfolio, okay, so that's what I'm looking for. If I want to be diversified as an investor, I am looking for very little correlation in the asset values in my portfolio, because then the risk of the portfolio as a whole will be less than the total weighted average risk of each individual asset in the portfolio. It would be no use my buying 5 different assets in my portfolio and they are all positively correlated, strongly positively correlated, because then that means that my risk is basically extremely high for my portfolio as a whole, because if something bad happens to one of my assets, all 5 of my assets are going to be affected in the same way. So my whole portfolio will take a dive. Whereas if I've got a portfolio of 5 different assets and they are negatively correlated or no correlation, and perhaps there is a slight little bit of positive correlation between some of them, if one of my assets is then affected by something in the environment, my other assets will either go in the opposite direction, which hopefully will be positive, or otherwise they won't be affected at all. So my total investment remains stable. But overall, there's far less risk in my portfolio. So that's the whole purpose of diversification. Okay. So remember we said that in terms of risk, a financial manager can be risk-taking, risk-neutral, or risk-averse. So most financial managers are risk-averse, and so they will want to diversify to a degree at least. So this is why the use of correlation is an essential tool for a financial manager to efficiently manage the portfolio of assets that they are managing on behalf of the company that they work for. So in that case, they will look for assets that have got a negative or zero correlation between them, because that's going to reduce the variability. Okay, another word for that is volatility. Remember, we said that risk, volatility equals risk. So that then reduces the risk in our entire portfolio. So if we look at the graph on page 81, that is a graph of a diversified portfolio. So if we were to graph the assets that were in our control, we would want it to look something like that. Okay. We've got two assets, A and B, and we can see that when the one goes up, the other one goes down, and vice versa. So the black line drawn through the graph that represents the total portfolio, you can see that that line is quite flat. It's much flatter than the individual lines of the two assets. So that shows the effective diversification has flattened the risk of my portfolio. Which is obviously a good thing. That's what we're looking for. Anyone got anything that they want to ask or observe or say, questions at this point? Are you guys okay where we are now? Okay, awesome. Then this part here, the impact of international assets on our portfolio. You guys can read through that on page 82 and your own, as basically just so that we are aware as financial managers that when we are dealing internationally, that can also help us to diversify, but that also, because we are now investing internationally, that brings some other risks into account that we have to be aware of. So the drawbacks to international diversification are that in that case, we're then exposed to foreign currency fluctuations, to political risk in countries other than just our own country, and then also different fiscal policies, which means that the other countries' interest rates can change differently to our own country's interest rates. So you've got political uncertainty, exchange controls, and various other things like that as well. And then very importantly, and you can follow this in the graph on page 84, is then within the environment that all investors operate, there are two types of risk: unsystematic risk and systematic risk. And we have to also be aware of what the two different types are, because the one we can diversify out of, and the other one, as long as we are investing in the same environment, we cannot diversify out of it. So if you look at the graph, you have got a parallel dotted line or a horizontal dotted line going across the graph from left to right. And your y-axis from the bottom at 0 going vertically up is the amount of risk in your portfolio. So from 0 at the bottom up to that dotted line, that is your systematic risk. And you can see that no matter how many assets I have in my portfolio, which is represented horizontally along the x-axis, that quantity of risk does not change. Because regardless of what industry I am invested in, that systematic risk exists across all of them. So another word for that would be inherent risk. So in one country, I have got the same political risk, the same interest rate risk. I've got the same risk of what else could, like natural disasters, etc., weather type risks happening, because it's all with I'm within the same environment. And systematic risk we cannot diversify out of. Whereas unsystematic risk is company-specific risk or industry-specific risk, which means I will only be affected by that particular risk if I own assets in that company or that specific industry, which is also then why investors will purchase in their portfolio of assets shares across different industries. So they might purchase in the mining industry, they might purchase assets in the food and beverage industry. They might purchase assets in the textile industry. 3 completely different industries with 3 completely different unsystematic risks. So in that way, I'm diversifying. But all 3 of those assets would have the same systematic risk. Okay. So that graph on page 84 describes that very nicely for us. So again, these slides, you can go through them and you can read the section in the textbook to understand it, unsystematic and systematic risk. And it is important that you understand that because we do again apply that further on. Okay. So again, we say as compensation for accepting systematic risk, which is undiversifiable risk, an investor expects a higher return than any asset that is, so to say, risk-free. Okay. So guys, that brings us to the end of this first set of slides that we have on Learning Unit 3. Where are we now? We are sorry, I'm just going to find this next set and open that up. So if you have a look at the screen, we can take a quick look here. So on the screen here is everything we've had a look at LU3 so far, all the different definitions of risk and return, the types of risk and how we measure risk, the techniques that we've got. And then the rest of this is then looking at CAP, which is the capital asset pricing model. So this is in your textbook starting from page 85. And if you have a look, this is important. This is a little paragraph that appears on page 85. CAPM calculates the appropriate required rate of return for a particular asset, meaning if I am an investor and I am wanting to purchase a particular investment, I need to know what rate of return I should expect from that asset given that asset's general risk level. Okay? Calculate an appropriate required rate of return for a particular asset for a given level of systematic risk. A systematic risk, remember, is the risk that will be inherent in all of my assets under the assumption that that particular asset is going to be added to a diversified portfolio. Because then remember, all the other assets in my portfolio will be exposed to that same systematic risk. So because of that assumption, I can then calculate CAM. That's just a description of beta. You can read through that in your textbooks. Interpreting betas, we'll have a quick look at that. And then just have a look at, yeah, so let's just have a quick look at this interpreting betas. So remember, in our CAPM formula, one of the variables is beta. So if I've got 5 different assets, each one of those assets will have a different beta. Okay, because the beta of each asset represents the quantity of risk linked to that specific asset. And then I am going to measure my assets beta versus the market as a whole. So the market as a whole means, let's say, for instance, the entire Johannesburg Stock Exchange. That entire market, all of the assets making up and are traded on the JSE. I say that that whole entire market has got a beta of 1. That's kind of like my starting point, the base of my index. And then I measure each individual share versus that average of 1. So some of them will be positive, so some might be 2.0 as opposed to the 1 of the market, and some might only be 0.5 as opposed to 1. And I could also have a beta of an asset. Sorry, this one is negative. It's positive 0.5, or I could have one that's negative 2. So again, if the beta is negative, it just means that that particular asset is negatively correlated to the market as a whole. And if the beta is positive, then it means if the market as a whole increases, then that asset that I'm invested in will also increase when the rest of the market increases. So again, that will indicate correlation with the rest of the market. So again, now I've just got a measure that will give me kind of idea, again, of the amount of risk in my particular asset as opposed to the rest of the market. We've had a look at that beta. Okay, that's in your textbook. You don't have to worry about that formula for calculating beta because you won't have to do that. The value for beta will always be given to you in any test or exam. So here's our CAPM formula, which says that the required rate of return, and this is important to remember because later on in this module, and next semester as well, we use this CAPM formula. So it's important that you understand what it is calculating, which is the required rate of return for an asset, is equal to the risk-free rate of return in my market as a whole, plus the beta for my asset that I'm trying to measure, multiplied by the expected return of the market as a whole, minus the risk-free rate of return of the market. Okay, and then I don't know whether you guys remember if you were told this, that the value for RM minus RF, in other words, market return minus risk-free rate of return, is equal to the market risk premium. Okay. So basically what we were saying is we take the market risk premium and I multiply that by the beta for my particular asset, and then I add to that the basic risk-free rate of return. And that then give me the expected return that I should expect to get for the asset that I own. So that's almost like a target. It's like working out the target profit that I should expect to earn from this particular asset. And then I can measure that target against the return that that asset is currently giving me, and then that will tell me whether my asset is underperforming or overperforming based on its expected return. So the most important thing with this here in Learning Unit 3 for CAPM is that you understand what it is calculating and that you understand those different variables that we are using in that formula. And then again on page 89, we've got the pitfalls of the CAPM formula. Again, remember, because every time we have a formula, then that means we are making certain assumptions. And as soon as we make certain assumptions, we have to understand then that that has got some downfalls to it. So example 3.11, you practice in calculating an expected return for a particular asset. And then you can do question 3.8 on page 88 to practice that. Here, the slide discusses the pitfalls, which you can read through in the textbook. And again, this is just another discussion on why investors do hold diversified portfolios, and what they call here the single period transaction horizon, which again is just some theory for you to look at. And this also, investors are able, these are the assumptions that we are making in this discussion that you can see on these last two slides. These four assumptions. Investors hold diversified portfolios, that there's a single period transaction horizon. All investors are able to borrow and lend at the risk-free rate, and all investors have got access to perfect information. Okay. So that's the end of Learning Unit 3. is more or less the end of the foundational learning units that gives you guys the basic formulas and concepts that we're going to use for the rest of the year. So I'm going to stop there. I know 5 minutes over, but I did start 5 minutes late due to my coffee incident. So guys, we're going to stop here for a 10-minute break. And just to remind you that if you guys are sitting on campus somewhere, they did ask us to remind you, bootcamp guys, that when we have the breaks, you're pleased not to go wandering all around the campus, because they have to deep clean everywhere that a student has been. So that's why you're confined to the classrooms where you are being socially distanced. And then in between each boot camp, they come into that one classroom and they clean that one classroom. And obviously you are allowed to use the bathrooms, but going between your room and the bathroom is the only places that you're allowed to go. Okay, all good. So I will see you back here in 10 minutes time, and then we'll have a look through Learning Unit 4. Okay guys, see you in a minute.